Alright, hello everyone. My name is Umar Shahid. Today I'll be showing you how to use the Nanovea ST400 interferometer. This device uses white light to get scans of the surface height of different samples. So the first thing we're going to do is remove the covering from the Nanovea. Put it up here. We have to make sure we put on gloves as well. Okay, so first we have to make sure we put on gloves. We're going to go ahead and turn on the light switch here. Turn that on. And then turn on the control switch here. And then next we're going to turn on the software, which allows us to control what the Nanovea is doing. So go to Nanovea 3D. And from here we can start to set up our sample. So in this video we're going to be scanning this 8 by 8 millimeter square on this sample. So let's go ahead and place the sample on the stage. So if we look at the Nanovea 3D software, we see that there's no height or intensity readings here. So what we have to do is we have to adjust this height spindle here on the Nanovea so that we can get good enough height and intensity readings. So if we go back to the software, we can see that we're starting to get some sample or some readings. So we want to get the height about in the middle, so around 600, and our intensity shouldn't be fluctuating too much. So if we move the sample around, we don't want to see it go to 100. So what we're going to do is we're going to go to acquisition rate, and since this is a lower reflection material, we're going to go to 30 Hertz, which is a lower acquisition rate. And then we're going to go to dual frequency. So that'll stabilize the intensity. We don't want it to be too high because the scan will become oversaturated and we'll have inaccurate data. What we're looking for is this little light. Right here. You can barely see it, but if we move it around, it's pretty noticeable, especially on this non-reflective sample. So I'm going to go to the top left corner right here. Okay, so once you have your sample with the light at the top left corner of the scan, where you want to scan, we're going to go over here to the software and make sure that we have X and Y checkboxed right here, and we're going to go ahead and press reset. So what this is going to do is just set everything to 0. So that's our reference point. The next thing we're going to do is, if this hasn't been clicked on, we'll click on it so that all these things light up here, and then we're going to click on these movement buttons to move the stage such that the light goes to the top right corner of where we want to scan. Okay, so once you're ready to start scanning your material, we have a variety of different scan options that we can choose from. First, we can either scan an area, which will scan dimension, X by Y dimension of area, or we can just scan the profile, which is just one single line of data. Also, we have starting position, where we can start where we place the light at, or we can start in the center of the scan, which will start from the center and actually fill in the rest of the data from there. Additionally, we also have single direction, dual direction, and step-by-step scanning types. Single direction will scan left to right, top to bottom for the scan. Dual direction will go left to right, and then right to left, and then left to right, all the way down from top to bottom. And we also have step-by-step, which will scan each point individually and takes the longest amount of time out of these three. So for this video, we're going to go with the single direction scan. Also, you have an averaging, which allows you to pretty much scan the same point multiple times and then take the average of that. So this will allow you to get more accurate data. And then next you have scan parameters. And this is where you're actually inputting where you're scanning. So this is once you determine where you want to scan, you have your dimensions and you divide it all by 4. You can input the X distance where you want to scan. For this video, we're going to put 2 millimeters because our square is 8 by 8 and it divides it by 4, so that's 2. And then the step size allows us to control like how fine our data is. So let's go with the step size of about 4 just for this video. And then for the y axis, we're going to also go 2 millimeters. And then step size of 4 for this. And as you can see on the bottom right corner here, as you change the step size and the area of the scan, the estimated time will also change. So there's a compromise between accurate data and length of time that it takes for it to scan. So if you want a very accurate scan, you're going to have a very long time of scanning. And then finally, before we scan, we want to do what's called a dark signal. So when whenever you're ready to start scanning your sample, you have your distance set up and your step size ready, and you got your acquisition rate and dual frequency setting right. You can go ahead and press start to begin the scan, and we can go over to the Nanovea. So once you start your scan, this is what it's going to look like when you have the single direction setting set. It's going to go line by line, left to right, from top to bottom. Okay, so while it's scanning, you'll see it's filling in the data right here. And right now it's going to take like 23 minutes for the rest of this scan to be done. So now we just pretty much wait. Okay. Alright, so whenever you finish your scan, you should have a complete scan here in this rectangle. You're going to go to hit save right here. And then from there, we can click and choose wherever we want to save our file. We can go to the desktop or any of these folders here. For this video, I'm going to go and save it in my folder. I'm going to name this file video 1, video 2. And then it's going to prompt us to ask if we would like to save the height or intensity data. And we're going to hit OK. And now our file should be saved.